Hi, I'm Jed.
I'm Josh.
And this is our question. After determining the voltage of a small coil inside a bigger coil, what is the maximum current in the bigger coil?
So for here, we've actually set up a little experiment to test this out. To show you what we have 120 volt power coming from the wall into a switch, which then goes into a second switch, which has a mini 15 amp fuse breaker. The reason we have all of this is for safety. Most power outlets are rated for 15 amps, so we want to have a trip on our mechanism that if we go above 15 amps, that it'll trip here. Also, everything inside the 120 side of the system is grounded. So then we can close that. And from the 120 system, we'll go into this 120 to 16 volt transformer. So that's going to output around 16 volts. From there, it's going to go into our larger yellow coil. And we have three 1 ohm resistors in parallel to act as a load and to regulate the current going into our big coil. And then inside the big coil, we have this little coil. And then we put that in there and we can measure, because we have a dummy load, a 1 ohm dummy load on the little coil to be able to measure the voltage being put out, the induced voltage in the little coil. The big coil is made out of 16 gauge wire. The little coil is made out of 20 gauge wire, which gives us about a 1 to 2 ratio in number of turns. The number of turns in the big coil is going to be 53. The number of turns in the little coil is 100, and both coils are 0.15 meters long. So for this setup, what we do, first we want to turn on our switch at our fuse, and then we'll end up turning on the switch at the thing. But first I want to make sure I'm ready to measure voltage. So as you can see, I'm measuring voltage. It is currently at 0 volts. I turn it on, and you see we're now outputting 2.1 volts. And I change this to hertz. We got up to 2.3. Change that to hertz. And as you can see, we're at roughly 60 hertz. Turn the switch back off, and we're down at zero hertz. And as you also notice, I have a couple of blank wires down here after the transformer. The reason why we can have exposed wiring after the transformer is, one, it's insulated all from the outside via the board, and it's less than 30 volts, so no other electrical safety requirements are required. And then finally, we can pose the question, say we know we got 2.3 volts, so we're going to write that E induced voltage equals 0.023 volts. So now Jed's going to explain to you the math and how we figure out the max current.
Alright, so like we said earlier, for the small inner loop, we have 100 loops, and then for the bigger yellow coil, we have 53 loops. Both of them are at 0.15 meters in length. Our input is 60 hertz, which is also equal to 120 pi rads over seconds, which is our omega. Our current in is equal to the max current cosine omega t. The magnetic field of the solenoid is equal to mu naught times the number of loops in the yellow coil over the length times Imax cosine omega t. Our magnetic flux is equal to B times A times cosine theta, and for our theta we have 1, which is equal to mu naught times the number of loops over length times Imax cosine omega t times the area. For our area we have which is equal to 0.0125 squared pi. Our voltage is equal to negative the number of loops in the white coil times d of the flux over dt. Our max voltage occurs when sine omega t is equal to 1.
d theta dt.
Explain d theta dt.
Okay, so our d flux over dt is equal to negative mu naught times n over L times the area times max current omega sine omega t. And then we have our voltage is equal to the number of loops in the white coil times mu naught times number of loops over length times the area times current max current omega sine omega t, and our omega t is going to be 1. Our Imax is equal to voltage over number of loops in the white coil times mu naught times number of loops over length times the area times omega. So finally we have our current max is equal to 0.023 voltage over 100 times 1.26 times 10 to the negative 6 Tm over area times
amps
times 53 over 0.15 meters times 0.0125 meters squared pi times 120 pi, and that gives us, so our Imax is 2.79 amps.